So we'd like to get started.
We got to go through.
Shut the doors. My name is Claire Finkelstein, and I'm one of the founders and the director of the Center for Ethics and the Rule of Law. CERL is a nonpartisan, interdisciplinary institute dedicated to the preservation and promotion of the rule of law in 21st century warfare and national security. The only center of its kind housed within a law school, CERL draws from the study of law, philosophy, and ethics to answer the difficult questions that arise in times of war and contemporary transnational conflicts. CERL holds 2 major roundtable working group conferences a year, as well as several one-day events, public sessions, book talks, all relating in general to the question of how to meet the challenges of abiding by the rule of law in today's national security environment. We also conduct ethics briefings and produce white papers designed to bring awareness of ethics and rule of law values to a broader audience. We work with public servants, members of the armed forces, policymakers, industry leaders, veterans, and veteran support groups, in addition to academics drawn from a variety of disciplines to discuss and make progress on the pressing ethical issues of our day, with a particular focus on national security. So I'd like to begin by just saying how excited we are to bring this very interesting program to you today. It really represents an evolution in CERL's work, and dare I say, is the furthest out topic we have yet addressed. We have focused very much on new technologies and the implications of new technologies for ethics and rule of law issues, and there is no place more complex and interesting than outer space for looking at many new technologies, and as well as the intersection of many topics that we have already discussed, including cyber technologies, robotics, and others. Most of us think about space in terms of science fiction or futuristic human exploration, but space technology is an integral part of our 21st century lives. We use satellites for internet, telecommunications, television, banking, GPS navigation, aviation, weather and climate tracking, health services in hospitals, disaster management, and much more. Similarly, the military is highly dependent on satellites for communications, tracking of troops, navigation at sea and in the air, piloting drones, and guiding weapons. If we were to lose the use of satellites for just one day, it would be catastrophic both for civilian life and for military operations. The space age began in 1957 with the launch of Sputnik by the Soviet Union, the first man-made satellite. The space race that ensued between the US and the Soviets was an outgrowth of the Cold War, namely a race to dominate technologically. Many early satellites were developed specifically for intelligence and surveillance purposes, and thus the militarization of space was already a fact in the early years of the space age. Both the Soviets and the US undertook weapons tests in space in the 1960s and very quickly realized that it was difficult to target only an adversary's satellites without also impacting one's own satellites or impacting the ability to use space in the ways they wanted. So already in 1967, both superpowers were willing to negotiate the Outer Space Treaty, which today remains the framework treaty for all activities in space. Today, space is an integral part of warfighting on land, at sea, and in the air, but this dependency of technologically advanced militaries on satellites makes them vulnerable. An effective way to cripple an adversary's ability to navigate, communicate, observe, effectively to fight its wars would be to take out its satellite capacities. There are many different ways this can be done without the use of nuclear weapons. So we are only steps away from space becoming the next domain in which we will see an armed conflict taking place. Tonight's panel will therefore address how the military uses space, what is meant by war fighting in space, and what the applicable law is that constrains or guides military activities in space. I'm really thrilled that for this venture we've been able to partner with several excellent partners, particularly Analytical Graphics Incorporated, or AGI. I'm very grateful to AGI and to Paul Graziani in particular for engaging with us and for being willing to embark on this interdisciplinary joint venture. We're also grateful to the Canadian Department of National Defense, the Engagement Program, which supported us with a grant for this program, as well as the Secure World Foundation. And we're also very grateful to the Penn Journal of International Law. I'm thrilled that we've been able to partner with the journal and that our students are very much involved in this effort and will be present throughout our ensuing roundtable, which will take place in the next couple of days. I'd like to introduce now CERL's Acting Executive Director, Cassandra Steer. Dr. Steer is the former Executive Director of Women in International Security in Canada, as well as the former Executive Director of the McGill Institute of Air and Space Law. She previously taught at the McGill Faculty of Law, and before that at the University of Amsterdam. She specializes in space law, public international law, international criminal law, law of armed conflict, criminal law, and comparative law. I'm going to let Cassandra do the introduction of our panelists, and just before I finish, I'd like to invite you all, after the panelists finish, to a reception that we have upstairs in what we call the GOAT area. And finally, I'd also like to recognize the partnership, informal partnership with the Air Force JAG Corps. We're really thrilled that we've been able to consult you extensively and benefit from your expertise, and thank you so much for all those of you who engaged with us and helped to make this possible. Thank you.
Thank you, Claire. I'm going to introduce our panelists, and I'm really excited by the amazing people I have sitting next to me. And then I have a couple of very brief videos, which I hope I'm able to show you, to give a bit of a context, because I'm aware that for a lot of people, apart from the comments that Professor Finkelstein just gave, the context of war fighting in space may not be so evident. But firstly, to my right, we have General David Thompson, who just yesterday was sworn in at the Pentagon as Vice Commander of Air Force Space Command and received a 3rd star on his uniform, so congratulations. I'm very pleased that you're able to join us immediately after your upgrade. But General Thompson has a long experience, a long career engaging with space and Air Force Space Command. His task as Vice Commander is to be responsible for organizing, training, equipping, and maintaining mission-ready space and cyberspace forces and capabilities for U.S. Strategic Command and other combatant commands. And if you're wondering what Space Command does, we're going to hear more about that from General Thompson, but it oversees Air Force network operations. It manages a global network of satellites for many purposes: command and control, communications, missile warning, space launch facilities. And Space Command is also responsible for space system development and acquisition, and sometimes in partnership with commercial entities. It's no small command. It comprises 36,000 space and cyberspace professionals in 134 locations around the world. We also have Dr. Laura Grego, to General Thompson's right. Dr. Grego is the senior scientist at the Global Security Program with the Union of Concerned Scientists. So the Union of Concerned Scientists was founded in 1969, around the time of the Vietnam War, by scientists and students at MIT. And it has a very specific mission, calling for scientific research to be directed towards solving pressing environmental and social problems, and not only directed towards military technologies. It's an advocacy organization. It has programs focused on climate change, sustainable energy, food and agriculture, and of course global security, which is what Dr. Grego focuses on. She's written widely. She's often cited in the news. She has over 30 peer-reviewed articles on issues such as cosmology, space security, and missile defense. And we have, right at the end here, we have Mr. Steve Oswald, Rear Admiral Steve Oswald, now retired, former NASA shuttle pilot. And I always think it's super exciting to hear the experience of astronauts, those who've actually been up there into outer space. He's completed 3 missions to outer space with a total of 33 days in space. In 1992 and 93, he piloted the Space Shuttle Discovery. And in 1995, he commanded the second flight of the Astro Observatory, which flew on the Space Shuttle Endeavour. His call sign is Oz. I think I'm going to refer to you as Oz, if that's okay.
That works fine.
A Bachelor of Science degree in Aerospace and Engineering. He's logged over 7,000 flight hours in over 40 different types of aircraft. So he was a naval aviator before joining NASA and beginning a career as an astronaut. And as with many astronauts, he went on to a career after his time in space in NASA in various different offices. He was the chief of the Operations Development Branch within the Astronaut Office and served as Assistant Director of Engineering at Johnson Space Center. So an extremely esteemed and knowledgeable and experienced panel. If it's possible, I think that we have the videos lined up. There's a very short video that I would like to show. I think the IT people at the back have that lined up for me. If not, then I will move straight on to asking you questions. It's unfortunate that I had 2 brief videos. One of them was simply describing a bit of a framework of the law applying to space. And the other one was a very short video put together by Analytical Graphics Incorporated, by AGI, which demonstrates just how many objects we have in space. So ever since we started launching objects into space in the 1950s and 1960s, there's been a constant incremental increase in the number of objects, up to hundreds of launches per year. And of course, most of those objects remain in space. So we have a huge problem of space debris, which causes problems of space traffic management, which is one of the issues of space security that Air Force Space Command has to deal with.
Could you speak louder, please?
Perhaps the mic can be turned up a little. Does that make a difference? Not really? I'm going to hold it like this. How's that? Should I start again?
Ready to launch the video.
Okay, great. Thank you.
Military activities today are highly, highly dependent on space technology. GPS that we use on a daily basis was a military invention, and it was invented so that they could track movement of troops, so that they could give GPS guidance to the Air Force, to the Navy, to track movement of ships and planes, and also to pinpoint the movement of adversary and being able to communicate via satellite movement in a remote area. All of these technologies are military technologies. They're also technologies that we use every single day. If military activities are dependent on space, then the best way to take out an adversary's capabilities to take out their eyes and ears would be taking out their space capacities, either by targeting a ground station where they're receiving data and information, or by targeting a satellite. And that's when we have the militarization of space and the potential weaponization of space. Star Wars is actually here and now. The next level of Star Wars, when we think about the kind of futuristic science fiction version of actual conflict taking place in space, we may not be very far off that scenario. We might only be a couple of years off that happening.
So that video was put together by a former mentee of mine. It wasn't meant to be a plug of my work or the Mackenzie Institute so much as just to provide a bit of an overview and a background. Could we show the next little video as well? So this is a piece put together by Analytical Graphics Incorporated, AGI, whose work is to track what's happening in space and provide data. And you can't really see the dates down the bottom very well, but it's literally going through the late 20th century and up to today, how many launches there are per year, how many objects there are in space. And that crowd of yellow objects you see around the Earth is operational satellites, but it's also space debris, so satellites that are no longer in use, small bits that have broken off from rocket stages, or perhaps a screw or an astronaut's glove. And that larger ring that you see further out from Earth, that is the geostationary orbit, which I'm going to ask Dr. Grego to explain a little bit more to us. But it's to demonstrate just how much of our activity is already in space, and just how much we use space. So I'm going to ask General Thompson, first of all, to give us a little bit of a background. We heard some brief comments from Professor Finkelstein, but can you explain to us how the military uses outer space? Why is space so important to the military?
Yes, thank you. I probably ought to try the same thing with my microphone. Can you all hear me in the back? Okay. First of all, let me say thanks to CERL and the sponsors and supporters of this symposium and the conference you have over the next 2 days. This is an important topic. It's an important conversation, discussion, and sometimes debate about where we need to go in terms of operating in space. In a military sense, in a commercial sense, in a civil sense, in general, it's probably an area of discussion and debate and development that has been stagnant for far too long for a lot of different reasons, and now is absolutely the right time to push this topic forward. And so I appreciate the work that you all are doing, as well as others in that regard. In terms of operating in space, actually, Dr. Finkelstein did a great job of defining why we need to do that. If you think about what a military needs to do, especially if a military is going to act on a global scale over wide ranges of the globe, the military needs to be able to sense globally and see globally. The military needs to be able to communicate globally, and a military needs to be able to navigate globally. A military needs to act globally. It needs to be able to synchronize operations globally. All of that either requires that you do those a whole host and series of missions from space, or you carry an incredible infrastructure with you, or you develop operating concepts that don't require that you see and sense and act and navigate and synchronize globally. And so really from space, you're able to do all of those things. You're able to do all those things with precision. You're able to do them in a timely manner. Anywhere, whether it's a broad ocean area, whether it's a vast expansive desert or jungle, anywhere, you may never know where you're going, why you're going there, what you're going to do when you get there from one day, week, month to the next. And so for all of those reasons, if you expect to do all of those things on a global scale, or at least a large part of the globe, you need to be able to do it from space. Otherwise, you won't be able to do it effectively.
And so then I would ask Steve Oswald, apart from those who desire to follow in your footsteps and become astronauts, why is space important to the rest of us who are not involved in military operations? I think I've started a trend, but you should be able to.
I should do it like the rest of the folks. So I'll answer your question, but since I dragged her up here, I thought I should introduce my beautiful wife. And a lot of people say that, right? And maybe not so much, but in my case, it's actually true. Mary is the former congressperson from Southern California, 15 years in the House of Representatives. So we were down sort of minding our own business in Atlanta at a conference on prescription drug abuse here earlier in the week. And we're getting up to head to the airport today, and I went down to check with the folks down at the desk. And all these guys were dressed up in golf clothes and headed out in cars. And I'm thinking, there's something wrong with this picture when you're leaving Georgia on the first day of the Masters. But actually, Mary and I were lucky enough to go to first golf tournament we went to was the the Ryder Cup at Hazeltine. We did 1 day there, and that was enough. Better to see it on TV. So we're both really glad to be here with you guys. I think the civil applications of space are at least as important as the military ones, and I don't think we've really seen that take off yet. Everybody knows about commercial satellites. Many of those are in geostationary orbit. Their throughput in terms of dollars produced every year, if you can get up one of those big balls up there successfully, is huge. So just the capabilities that those, whether it's TV or whether it's broadband communications of those large satellites, or smaller ones, capabilities like Iridium, where you can talk basically from anywhere on the globe, a very clever system, and they're reconstituting that capability now. But really the only two applications that are actually making money in space that I know of are the telecommunications folks, and to a lesser extent, some remote sensing that is going on the commercial side. The French do some of that, we do some of that, and that's turned into a fairly lucrative business. On the civil space side, one of my heroes, John Young, just passed away several months ago. He was unique in all the world, really, in that he flew on 3 different spaceships, twice in Gemini, twice in Apollo, walked on the moon, and then flew the very first space shuttle flight and the very first flight of Space Lab. But John used to say that single planet species don't survive. So think about that for a bit. And so it's not really a matter of whether or not another dinosaur extinction event is going to happen, just a question of when, right? Unless we do something significant having to do with planetary defense, which maybe the general can talk about a bit more later. But that has to do with kind of the Armageddon movie kind of thing of nudging an asteroid. But I think John's right. I think human space flight is important for a number of reasons. The collateral benefits that you get from human space flight, just in the doing of it, having to do with getting to work with the Russians and astronauts from another 35 or 40 different countries on the International Space Station. And I spent the first 10 years of my career trying to figure out how to kill Soviets more efficiently, right? It's a whole lot better to be working with them than it is to be trying to figure out how to sink the ships or shoot down their airplanes. So I think there are a lot of very intangible, besides just the making money side of the commercial business, but on the civil space side and space exploration is very important.
And I actually had a question I was going to ask you later, but you touched on it already, which is the cooperation, the international cooperation that we have, particularly on the scientific and civil side. How is it that we can cooperate, that the US can cooperate with the Russians, for instance, on the International Space Station so closely? And what lessons might we be able to learn from that?
Well, the lessons that I learned from it was that their pilots are just kind of like us, right? They want to be professional operators. They're very good at what they do. And we first got into working with the Russians in space, other than Apollo-Soyuz back in the 70s. It was the mid-90s, and they had a space station and we didn't. It was called Mir, which meant peace in Russian. And we flew a half a dozen flights to Mir, docked with shuttle on Mir. And then we got into the space station, the International Space Station design process. And the first 2 pieces that went up were the US node and a Russian piece docked together, and away we went. So we constructed that over probably a decade. And we've been flying with them now. I think one of the more misguided policy decisions that we made was to shut down shuttle before we had a replacement. So we've been flying with the Russians to the space station that we have paid for over half of, but we can't get there unless we go fly with the Russians. Now, hopefully we're going to fix that within the next 2 or 3 years. we should be flying a couple of different vehicles that have a U.S. flag on the side of it, and U.S. guys and folks from other countries flying that. But I think it's been just a marvelous cooperative effort. And the Russians, they think they're communists, but they're really pretty good capitalists. They really kind of like getting a paycheck for flying people from other countries. So yeah, it's been good, and I think that we have not seen the end of the benefits of that.
There's something very interesting about the cooperation, given how much competition that there is in space. Laura, I wonder if I can ask you perhaps two questions in one. So space is often described as congested, contested, and competitive, and I wonder if you could enlighten people as to what's meant by that. And if it's not too much, to also describe a little bit about the low Earth orbit and the geostationary orbit, how they work and what value those two orbits have, because that has a lot to do with the congestion, the contested, and the competition in space.
Sure, thanks. And first, let me take the opportunity to thank CERL and the sponsors of the conference and my co-panelists and everyone for giving this subject attention. I strongly agree that it's important in its time. And I'm Italian and a scientist. I'm going to have a really hard time only using one hand to explain orbits.
You can put the volumes up. So
okay, thank you. So good. So I think maybe I'll take those questions in the opposite order because it might help to do that way. So we saw in the video, in the back, it's okay? They said nothing. Yeah, okay. Perfect. Space is not just a place, but it's actually, being in orbit is actually sort of an action. So most of us, your terrestrial intuition doesn't work so well when you're thinking about space. I'm making the Earth with my hands here. The space station was only maybe 250 miles up, something about that, the distance from here to Boston, right? So it's actually kind of in the neighborhood when we're talking about low Earth orbits. So that's really part of the terrestrial system. But getting up to that altitude is not sufficient to be really part of the space environment. The real trick is getting fast enough to go around the Earth so you don't fall back. So when you see these giant space launch vehicles, and I'm sure most of us have seen pictures, right? It gets you up, but really what it needs to do is get you going fast. And so you're continuously going really fast. So the reason that we're in low Earth orbits, which are sort of that 250 kilometers to 2,000 kilometers range, is to get a good look at the Earth. Like there's a lot of things that you can do more efficiently from space. You can really turn back and look at the Earth and get beautiful pictures of the weather, Google Maps, spy satellites, communication constellations, environmental monitoring, all sorts of things that are really useful. So low Earth orbit is really sort of looking back at Earth, taking pictures. So then a little bit further away, you have where the GPS satellites are, and other GPS-like constellations. And those are meant to provide a navigation signal. GPS was a Navy program, I believe, to start with, a military program, but basically provides location signals and thank you. Air Force flies it. I'm going to stumble all over those things. But thank you, Pentagon writ large project. Thank you. Well, I mean, now it's a global utility. It's something everybody uses, and not just the location signals, but the timing signals. It coordinates cell phone calls and banking transactions. I can't remember. It's used like 100 million times a day or something like some enormous amount. So it really underpins lots of things. So that's the next step further. That's like 20,000 kilometers away. And that allows you to have this big constellation, so you always have enough satellites in sight to do your triangulation. And then further than that, like 6 Earth radii away. So that's what we call geostationary orbits. And that's a special place, a very valuable place. Because as I mentioned, staying in space, you need to go fast. You're going around and around. And the rate that you go around and around depends on how far from Earth you are. So as you're out here, you're kind of going more slowly. And you can imagine that if you get to the right altitude, you're going around at the same rate that the Earth turns. So from the Earth, it looks like that satellite is always right above you. So if you put a satellite dish, you don't have to keep tracking it across the sky. You just set it up and you're looking at the right satellite. And also from back there, you can see most of, the hemisphere of an Earth. So if you wanted to broadcast to a wide range of people, it's a pretty efficient place to do it. Or if you wanted to communicate from, one far distant place to the other, go up through space, that kind of thing. So those are super valuable. Those, limited slots, those are sort of around the equator. So hopefully I gave you this shortcut, which in your mind you say, being in space involves going fast. Well, that's sort of, so one reason you can sort of say congested, contested, there's no place on Earth, like above us isn't Philadelphia. It isn't the US. Satellites are moving, so everyone's moving all together. Everyone's in the mix all together. Satellites are all in the same space, so we have to kind of share, or in an organized, efficient manner, share that space. So you can imagine sometimes you have to do a lot of coordination, so there's some competition. People want to use that valuable geosynchronous orbit, for themselves, and it's a first come, first serve kind of organization. Or it might be extremely valuable. Your military, it might have a military or commercial use, and you might want to deny a potential adversary that use. So that's a competitive, or there's a contested. So there's a lot of mix here. And then the last, congested, there's a lot of us out there. We saw this great video from AGI, which demonstrated the kinds of satellites that are out there. So those dots weren't to scale. They're actually much smaller. But there's a lot of, space is big, but there's a lot of stuff out there. So one thing we do at my organization is try to keep track of the satellites that are actively working. There's around 1,700 satellites. Over 60 countries own one or a large part of one. Everyone's invested. Even if you don't own a satellite, you're using satellite services all the time. But there's a long history, 50 years up in space, a lot of detritus, as we said, bolts and bits and pieces, and sometimes old rocket stages explode. And that the issue is, once you're up there and you're going fast, if you explode, that doesn't mean you drop back to the Earth. You're still going fast. So you got stuff that's in the way. So you've got actively working satellites, and you've got this buzzing ball of space debris. So that's essentially congested, and competitive.
And so with that context, General Thompson, maybe you could talk to us a little bit about space situational awareness, because that's one of the key things that Air Force Space Command does, and not just for the US, it provides that information internationally. So what is space situational awareness, and why do you share that information? Why not just keep it for the US?
You're exactly right, it is. It's space situational awareness. There's a few different definitions you might use, but it's really an understanding of everything that's going on in the domain. It might be from a physical standpoint, it might be from an electronic standpoint, it might be from a space weather standpoint. There's a lot of elements to it, but when we think about space situational awareness, typically we think about those objects that are in space continuously moving and the potential hazard they might pose to themselves or others. As Dr. Grego said, there are various objects in various orbits. Today, Air Force Space Command tracks about 23,000 of those objects. When you think about the size of them, we can reliably track objects down to about what we call basically 10 centimeters, which if you ball your hand into a fist, that's about the size of those objects. Now, my hands are a little bigger than most, so if you think about a baseball, that's about how large of an object we can track. First of all, track and predict the orbit of reliably. Unfortunately, conservative estimates say there are at least 10 times as many objects in space that we can't track that are smaller. The conservative estimates say 200,000 objects perhaps. Others say perhaps as many as 500,000 objects in space, and as Dr. Grego said, when they're traveling that fast, 17,000 miles an hour, they don't have to be very big to pose a hazard to others from a collision standpoint. And that was demonstrated actually back 10 plus years ago when a Iridium satellite that doesn't have the ability to maneuver in orbit, it strictly moves based on physics, and a dead Russian satellite called a Cosmos satellite that no longer had the ability to maneuver, by accident collided with each other. And that collision created over 2,000 pieces of additional debris instantly. And as Dr. Grego said, that debris does not fall to Earth. It remains in orbit, and you now have basically a shotgun blast of debris that's ever expanding, moving at tremendous speeds. And so when that happened, because we have a global network of sensors, both on the ground and in space, we have radar, we have optical sensors, we have sensors in space to keep track of those things, the Air Force decided at the request of the United States government to take all of that information we had and share it publicly. We do it in a couple of ways. The first thing we do is we publish a catalog of all of those objects we can reliably track, 23,000 or so of them, where they are, where they came from, what orbits they're in. But the other thing that we do is we continuously do what's called collision assessment, or I'm sorry, conjunction assessment. And we look at, propagate all of those objects in their orbits over time and look for when they potentially pose a collision hazard to each other. And we advise those organizations that own and operate those satellites that there may be a risk. We do it routinely and very carefully for the International Space Station, obviously, because human life's at risk. But we do it for, we did it for the Chinese with their space station. We do it for owner-operators of commercial satellites. We do it for any object in space for which there's a collision hazard. We will provide a warning and then let those operators decide. We give them parameters and let them decide whether or not, if their objects are maneuverable, if they want to maneuver them out of the way and do those sorts of things. That's from a, what now is increasingly called space traffic management perspective, why you want to know what's up there, where it's going, where it's going to be. But then there are obviously also, from a military perspective, other reasons why you want to know where objects are, what their capabilities are, what their behaviors are, and what they might do in the event that they pose a threat to your space capabilities, your satellites, or others. So there's a whole host of reasons why you do it. The Air Force does it today because we have the ability to do it, first of all, and because we see the value for the world writ large in protecting that global commons that is space for the user.
Which is quite a benevolent standpoint to take. I mean, you have the information. It might also be possible to withhold that information if you wanted to allow the Chinese space station, for instance, to be impacted, or the satellite of an adversary to be impacted. And so there's a kind of benevolent stance in that, and that has to do with the need to keep being able to manage and use space for our own purposes. And yet, and the Outer Space Treaty, the 1967 Outer Space Treaty, which in that video I said remains the framework for all of today's space activities. One of the cornerstone principles in the first article is that space should be used for peaceful purposes. So does that not come into contention with military uses of space? And I also want to ask, because the Air Force describes space as a war-fighting domain, which is part of the title of tonight's keynote. How do those two principles interact? Is it not contentious to say, on the one hand, peaceful purposes, on the other hand, it's a war-fighting domain, and we want to be able to win the wars that we're in?
Perhaps it is, but I guess I look at it this way, and I would describe it this way. I think if you look at any domain out there, you know, that we deal in routinely, obviously we deal at land, we deal on the oceans of the world, we deal in the airspace, we deal in cyberspace. I think I would argue that, and in space, in all of those domains, the desire for all should be and is that we use those domains whichever way we use them for peaceful purposes. I think we had the opportunity early on at the dawn of the space age to try and establish a precedent that said we'll use this for peaceful purposes. I think, you know, it was interesting for a couple of reasons. First of all, in that era, other than when, as you talked about, the use of nuclear weapons in space was incredibly dangerous and incredibly destructive, not just for individuals or individual satellites, but for the entire domain and for everybody that operated. And so that, back in those days, that was really the only ability to affect the domain from a warfighting perspective. And so it's very obvious and easy agreement for nations of the world to reach to say, we should not treat this the way we treat other domains. And it's a great objective and a great desire. But on the other hand, I think we have to recognize that We are human beings who have tendencies that have been exhibited over millennia. And just as we did on land, just as we did at sea and space, you notice we never had a discussion about the use of cyberspace for peaceful purposes. So we have to acknowledge, unfortunately, that we're human beings that have exhibited traits over the years, and we try. And that's why I think the work that's going on right now through Millimos and the Woomer Project and others is to early on establish and understand and acknowledge that our nature says we're going to use this for whatever purpose we need. And the more we can work on establishing behaviors that we all understand, that we all accept, that we all can describe and use in terms of what's hostile and what's not, it's better to move forward in that way now than to try and say, this is a domain used for peaceful purposes. I think we have to acknowledge we absolutely want it to be, just like we do the oceans of the world, just like we do the airspace of the world, but understand, acknowledge, and recognize it will be used in a contested sense. And the better and the quicker we can get after how we do that appropriately and ethically and legally, like we do in all other domains, I think probably. So it's a balance in space, just like it is in any other domain.
And you mentioned there the Millimos and the Woomera project. So Article 3 of the Outer Space Treaty says that all activities in outer space have to be in accordance with international law, including the UN Charter. So that means that the law on the use of force applies. All use of force is prohibited unless in self-defense or unless authorized by the UN Security Council. It also means that the law of armed conflict applies. But it's a little bit tricky perhaps to figure out how these things apply. So for the benefit of the audience, the manuals, the Millimos, the Manual on International Law applicable to military activities in outer space, or Millimos for short, is a project spearheaded by McGill University. And the Woomera project is spearheaded by the University of Adelaide and Exeter, both of which are set out to bring together international experts to try and clarify, how does the law of armed conflict apply in space? How does the use of force apply in space? And it follows in the footsteps of some other manuals. I wonder if you can you speak a little bit to the previous manuals and their value?
And I can only in a general sense. You know, I'm not an expert on those or the legal aspects, but certainly over the years, those manuals describe what really has happened in some cases over centuries, in some cases over millennia, and in some cases newly the Talon Manual with cyberspace. What we've learned as the human race over the years, as we engage in conflict, what's appropriate, what's not appropriate, how you do it in a manner that we consider appropriate for human behavior. But the difference is, as I said, you know, we've got the manual that deals with maritime, right? The laws of the maritime domain and rules of engagement, common practices. We have the same for air and missile defense. We have the same for cyber. We have a lot of experience, unfortunately, in conflict in those domains over years and centuries that have allowed us to develop. And so we've learned what's a hostile act, what's not a hostile act, what's appropriate behavior, what's dangerous behavior when you're in close contact with a potential adversary, those sorts of things. Really, in space, we haven't had a lot of time and a lot of experience in that regard for two reasons. One is while we've been at it for 50 years, the capabilities in space are still incredibly limited. They're dominated by physics. There's a whole lot of space out there and not a whole lot of objects yet. We're getting there quickly. But we really haven't had a lot of experience in what it means for one nation, one organization to encounter the other and how to deal with each other appropriately. And so I think we can learn from how we operate safely, sensibly, stably in the oceans, in the air, and in cyberspace. A lot of those principles can apply and be applied to Millimos and to the Woomera project. I've grown up, I spent my career in the Air Force in space, and for too many years our answer has always been space is different. Space is different physically, just like air and the oceans and land are different. But really, when it comes to human behavior, when it comes to principles and concepts, in reality, there's a whole lot more in common with what we can and should and approach behaviors in space as we do in those other things. So I think there's a lot to learn.
So those manuals, as you explained, there's the San Remo manual, which was developed in the early 90s to talk about, well, how does the law of armed conflict apply to warfare at sea? Because These laws were developed post-World War II. We have the Geneva Conventions. We have very clear principles, but they were written in a particular time when wars were fought in a particular way and technology looked a particular way. And so by bringing together experts to clarify what do we think the law is, how can we restate the law as applicable to warfare at sea? In the late 90s, we have the Harvard Manual, which focuses on air and missile warfare. And then you mentioned the Tallinn Manual as well, which is the early 2000s, about cyber warfare. What is an armed attack if we're talking about hacking into a system with a computer? I wonder, Laura, if I can ask you, now that these projects are underway to develop manuals regarding space warfare, is there a concern that putting these rules down on paper looks a little bit like writing a blank check or giving an instruction manual? This is how to go and fight a war in space.
Yes, as someone who's involved in those projects and someone who's from the peace community, I was concerned. And also, I'm not a lawyer, so I asked most of the lawyers that I know, what do you say about this? And I think, so you should, hopefully I sound that I'm faithfully reproducing those arguments, that in areas where there is no guidance, the assumption is that it's okay to do, and that clarity provides guidance about what's appropriate and what's not. So I would, of course, be concerned that it says, here's a how-to, but I think, I'm not qualified to answer this authoritatively, but I think what it does is especially provides clarity about when you do this, I can interpret it as this, or it is, we all agree, or at least the law says that this is, you've crossed this boundary and I've established what those boundaries are. I think the lack of clarity, and General Thompson has mentioned this, we don't have a lot of experience with each other in space, in a contested space. We really don't. The US and Soviets, then Russians, spent a lot of time in strategic talks, understanding the nuclear strategic competition, and when you do this, that's what this means. And of course, there's some ambiguities, but there is a lot of experience. Thankfully, we weren't fighting nuclear wars. But we don't have experience with each other that says, okay, if I do this, I'm intending to send you this signal. Are you receiving the signal that I thought I was sending, or something entirely different? We need a framework with which to interpret that, especially in a crisis. In space, things move very quickly, not just around and around, but because satellites are by nature very vulnerable, very difficult to protect. As I mentioned, the low Earth orbiting satellites are pretty close to the ground, so within reach of ground-based missiles that even spacefaring nations could field, non-spacefaring nations could field. And they're very valuable. We just spent a lot of time explaining why they're so useful. So something that's extremely valuable and extremely vulnerable at the same time. That kind of dynamic can lead to a use it or lose it kind of pressure. And that's definitely something that's not particularly helpful. So that compresses timescales for decision making. And so the more clarity around what's okay and what's not is helpful. And of course, hopefully we develop ways to talk to each other, so especially the major spacefaring powers and those who use it for military purposes are able to have these discussions, strategic discussions around using space, and so that we can get some experience, so you can get personal relationships, so you can get institutional relationships to manage these things when they come up. And a manual hopefully is also a framework for that.
And so I wonder if I can ask you, and I'm aware that you're not a lawyer, but I did let you know I wanted to ask this question of you. So you are an envoy of humankind. Article 5 of the Outer Space Treaty says astronauts are envoys of mankind, of humankind. It's a very special status. So there's this enormous respect for the training that you've gone through, the risk that you put yourself in going into the space environment. We also have the Astronaut Agreement, which expands on that and says if the astronauts are in distress or land on the high seas or in distress in space, or perhaps the capsule lands on the territory of a country where maybe there are tensions between the US and that country at that time. The Outer Space Treaty and the Astronaut Agreement both say there's an obligation to assist you and repatriate you. So there's a very special status. I want to ask you what you think it means to be envoy of humankind. Why do astronauts have that status? And then, again, I know you're not a lawyer, but if there were a conflict, an armed conflict between the US and country X, under the laws of armed conflict, you could be seen as a combatant. You have a military training, you're a military officer, naval aviator, and you're up there in space as an envoy of humankind. Do you think that the law of armed conflict should apply, and that would say that you are a combatant, a lawful target you could be? Or do you think that your envoy of humankind status trumps that?
B.
You personally, I think the answer is pretty clear. Can you elaborate? Why?
So, you know, it's funny when you, my first flight, we flew with a German and a Canadian, so not exactly enemies, at least not in this decade. And then we had international influences on another one of my flights, and now, of course, we're flying with folks from Japan and Canada and all over Europe. I think sooner or later we'll get a Chinese astronaut on board space station. I hope that that's true. But, you know, when you put together with these folks, you spend literally years training for a space station flight. My shortest turnaround was 15 months, right? So you spend a huge amount of time with them. You're more of a crew than you are certainly not adversaries. You know, not everybody gets along. You're not all bosom buddies, but just in the way you train for it, I can't imagine folks on the space station, if you happen to be Russian or American, doing anything that would be adverse health-wise or any otherwise. So let me backtrack, since I'm not a lawyer, but the history of this whole thing is kind of interesting. And to pile on a little bit on what Laura was saying, you know, once upon a time until the 80s, it was a bipolar world, right? Mutually assured destruction. And so we didn't, to my mind, worry a whole lot about folks doing untoward things in space, because the Soviets depend on their stuff and we depend on our stuff. And it's sort of a lose-lose deal if you were going to go up and try to take out somebody else's assets, whether or not you were doing it non-destructively, blinding a satellite that happened to have a sensor in it that wouldn't necessarily cause fragmentation. But if you do it to them, chances are pretty good they're going to do it to you, right? What's different now, and we saw this in 2007 when the Chinese started to get into the space flying business, and they did an ASAT test, probably just to show the rest of the world that they could do it. But they took out one of their own satellites in a near head-on collision with an orbital kill vehicle, and it produced on the order of, and the closure rate for this had to be in excess of 25,000 miles an hour, huge amount of energy, and it 1,500-ish trackable pieces, 150,000 estimated pieces, and that went on at about 500 miles, which is above a space station. But like anybody in the room that's maybe over 30 or 40, you know, gravity wins, even in space, right? And when those things go off like that, pieces go in every direction, and I'm not going to give an orbital mechanics lesson here because I probably couldn't do it justice, but stuff that goes up and forward stays higher, stuff that goes down and backwards goes lower, ends up faster. And what you do with 150,000 fragments, the best you can do is model it, right? So you're guessing where these things are going to be, and so you're flying through clouds of stuff, you know, whether or not you're an unmanned vehicle or a manned vehicle. And we hit a lot of stuff with shuttle. One of my flights, they took a Russian paint fleck out of the windshield of Discovery that had buried itself a 1/4 inch deep into a 3-inch thick windshield. But that's a lot of energy when a paint fleck can go a 1/4 inch into crystal. So it doesn't take much. If you're not armor plated, and we do end up putting some shielding up. Station has a lot of shielding. But when we know something's there, we move station. We'll climb it to a higher altitude usually because you don't want to waste gas, so we'll boost it up. But we'll get it out of the way, you know, and thanks to the Air Force, they send us the information. But, you know, I think I'd rather be an emissary of humanity than I would be some sort of a military guy in orbit. I just don't think that makes sense. And I think the Russians would agree.
So the reason I asked is because it is a slightly contentious question. Does the law of armed conflict trump the law of outer space, or vice versa? And there's no clear answer to that because they're both very specific areas of law. We call them lex specialis. The more specific the area of law gains priority, but we don't quite know how that plays out in space, although one would assume the answer that the people in the Woomera manual have come up with is we have to look at it case by case. Are you in space to perform a military objective or to perform a military act? Perhaps you could be a combatant. If you're up in space as part of a NASA program, probably you are protected. You're an envoy of humankind. But we don't really know the answer to it. And I would think that the kind of the moral tendency is, well, of course you should be protected. You're an envoy of humankind. The risks that you want to take to your life just to go into space and the kind of work that's being done there, as you've told us, is very much based on collaboration and cooperation. But you mentioned that
maybe we need a lawyer on every cruise so they can figure it out.
Take me. I'll volunteer. You mentioned this test, this ASAT test, this anti-satellite test that China undertook in 2007. Russia and the US have also undertaken ASAT tests, anti-satellite tests, not dissimilar, although the impact wasn't as great. And as
Last
you said,
one was, though, in '85, I think, that we did.
2008, I thought there was one more recently.
Yeah, and if you'd like, we can talk a little more about in 2008. It could be considered, you know, some might consider it an anti-satellite weapon test, but it really wasn't, and here's why. The purpose was, and for those of you who remember, there was a satellite that was launched that soon after it was launched suffered a catastrophic failure. It basically became a rock in space. Several years later, it was preparing to re-enter because gravity and drag win, not just gravity. The problem was it had failed soon after launch. It had 1,000 pounds of hydrazine fuel on board, incredibly toxic fuel, which was probably on the order of 55, 60 gallons of this fuel. And because it had failed early, the fuel tank was full and the fuel tank was frozen solid. So there was a pretty good chance that this titanium fuel tank full of ice, hydrazine ice, was going to survive re-entry. And if it did so, there was a potential hazard to human life, obviously, because it's incredibly toxic fuel. So the president at the time asked what options we had to do something about that. You know, of course, the chances were it was either going to fall in the ocean or some uninhabited part of the world, but they didn't want to take that chance. And so the United States at the time took what is a ballistic missile defense capability, and the U.S. Aegis cruiser ship that does ballistic missile defense, figured out how at the extreme limit of its range, with a whole global network of sensors stitched together over about 3 months of work to patch it together, to update the software, and do a whole lot of modeling, and wait until that object had gone far enough into the atmosphere to be able to, first of all, reach it, and second of all, ensure that the pieces did not stay in orbit, conducted that operation to be able to do that. What it doesn't, and then immediately disbanded the capability. So basically what they did was they waited till it was so low that they could reach it. It took about 3 months of solid work to develop the capability to be able to destroy and break that object into pieces before it re-entered and created a potential hazard. So some might argue that's an anti-satellite weapon. In reality, it's not a practical anti-satellite weapon because it doesn't have the altitude. But the other thing it didn't do was create debris that lasted. It all, in fact, I believe the last piece from that object re-entered in 2010. All of that debris re-entered the atmosphere. Today, 90% of the debris that was made by the Chinese ASAT test remains in orbit today. And so some people say it's an anti-satellite capability, not really an operational, from a military perspective, not really an operational one. So that's the difference. So the real answer is 1985 for the U.S. military.
And so,
Shot by the Navy, then, don't you think?
Probably guided by GPS.
Yeah, probably.
so we've learned from experiences which may or may not be anti-satellite weapons tests. China also denied that it was an ASAT test. China said, well, we're trying to get rid of a piece of defunct satellite, a piece of space debris, and here's one way we could do it, we'll destroy it. Whoops, we just created an awful lot more space debris. But we've learned from these tests or experiences, however you want to categorize them, that kind of kinetic destruction is probably the least desirable form of impacting an adversary satellite. So Laura, can you maybe describe a little bit about other kinds of anti-satellite tests or weapons that are out there that are non-kinetic, and what their risks or benefits are as opposed to physically destroying an object in space?
Sure. I guess with all due respect, I would note that that same missile defense capability will have an improved interceptor with faster speed. It's currently being jointly developed by the US and Japan, and those missiles could reach essentially all of low Earth orbiting satellites. And it will have the similar seeker, which has been demonstrated to be able to intercept satellites. So certainly there is a self-deterrence from using those against satellites because they produce a lot of debris. But certainly the US has that capability. Russia is developing such a capability. China has demonstrated that. So this capability to destroy satellites outright with kinetic effects is not widely held, but proliferating. India is developing a similar type of technology. So that self-deterrence effect, because essentially what you kind of do is set up as you mentioned, a shooting gallery. You have your detritus from your orbit you still have to operate in all of this. So people don't want to do things. But other ways to interfere with satellites, for example, the simplest technology and the lowest energy is to jam their signals, because a satellite that can't communicate with the ground or with anybody else is just a piece of debris. So interfering with your ability to speak with your satellite to get data back by blasting it with a stronger signal that confuses it, or hacking it, using a cyber attack to get in through its command and control, that's actually pretty difficult if it's a well-protected satellite. Those are the kinds of things that just interfere with your ability to communicate. As I mentioned, there are a lot of satellites whose jobs are, and you mentioned remote sensing, so satellites that are looking at the ground. So they have sensors, and those can be, perhaps interfered with from the ground by shining a laser, so that you either make it too hard to see, it's too confusing, or if you are dedicated and you get lucky, you might be able to damage the sensor if you have a highly powered laser and a tracking mirror and stuff, so you can interfere that way. Those are, sort of going from reversible and temporary and maybe not quite as provocative to things that when you start damaging another satellite, that certainly is problematic. Then you can, for example, instead of going up to a satellite and destroying it and ramming it with a force of impact, maybe come up close to it and so interfere with that satellite, not by destroying it, by set it spinning, or I don't know, I've heard outlandish things like spray paint the sensors, or doing something that's that doesn't slam it. It incapacitates your target satellite, but it doesn't make a big mess. And so that's a very sophisticated kind of technology, because getting up close between two satellites, getting them close together isn't something that normal satellites can do very well. You have to be a pretty sophisticated space operator. And people often say, yeah, well, we do that on the ISS all that. We've been doing that for years, but that's a cooperative. You're going to another satellite that's asking you to come close. This is getting towards a satellite that's hasn't invited you over and isn't helping you come close, right? So it's that's a different type of technology, and that's certainly there are good, very beneficial uses for that. You can inspect a satellite, you could refuel it, repair it, you could use that capability to build large structures on orbit, but of course at the same time, if you are able to approach somebody else, there's lots of things you can do to interfere. So I think there's, as you said, there's a self-deterrence from destroying satellites, but there's other ways to get at the problem.
So I can imagine that people in the audience have quite a number of questions, and in just 1 sec we'll open that up. But I guess I want to underline the key difference about space. I mean, as you said, space is the same because it's still human behavior that we have to look at. But there is a tension there in terms of, even if we want to dominate or take out capabilities of an adversary, we have to be careful about how that impacts us because of the physics of space. And space is highly integrated into terrestrial warfare. We use space every day. The military uses space every day. But there's a tension about taking conflict into space and the different ways that might happen. So I want to open it up to the audience to see who has
I actually
questions.
want to begin by asking the first question, if I may, to get us started, because I think that's something that Cassandra raised really needs follow-up, and I want to invite you to follow up on an important point that she raised. Cassandra raised the issue of whether or not an astronaut might end up being a combatant. But I want to raise the question about whether or not a satellite might already be a military target. Because if you have such heavy military use of satellites, suppose we are in a war, for example, in Syria, just to take an example. And suppose we ended up in a conflict, in a kinetic conflict with the Russians, say, in Syria. Wouldn't our satellites already, therefore, be a legitimate military target? Because if we're using those satellites to guide our troops on the ground, wouldn't it be fair game for them to take it out? That's my question.
So, so here, and I believe this is where we talk about the fact that we have experience in this regard in other domains, and I would argue that here the law of armed conflict does apply, or can or should apply in space just like it does in other domains, and that's exactly the case. If it's used for military purposes under the law of armed conflict, the answer is that it is a valid military target. But with all targets, once that happens, there's a second test that is applied, and that's the test of proportionality that says if it's a valid military target, you have to consider what else it's used for, what the impact is of its destruction, of striking it, what's collateral damage, those sorts of things. So I think what makes it more difficult, there's a couple things that make it more difficult in space. So many space systems are able to be used for multiple purposes, dual purposes, right? GPS was developed for a military purpose, but it's also the blue dot on your iPhone. So, so a lot of those, there's the US military, foreign militaries, all militaries, in fact, often use commercial communication satellite for their purposes. So I think here, what clouds the issue more so in space is so many of the space system's capabilities have the ability to be used for civil or commercial or other purposes, as well as a potential military purpose, that more often than not, probably you have to then answer the question of proportionality, because in many cases there is a military purpose. You then ask the question of proportionality. Should it be struck? What's the implications, and does that apply?
So there's a question over here. There's a microphone coming to you.
I have two questions for between Mr. Oswald and General Thompson. The first question about why can't we learn from the Russian the way they go to the moon and delivering Sputnik. They shoot their things out of space in a very efficient, practical way, and everybody's learning from the American technology. It's fair game now to copy the Russian technology. It's efficient and practical. The second question, in the wake of the dying of the generation that made the argument for the mutual assured destruction and used it to make the case for restraint between the Russian and the American, and use that argument to bring peace. I wonder if the new generation that is taken over, people in their 60s, they are more, in my opinion, they are more technocratic, they are so detached. I wonder if we have some form of technology for restraint, some form of law to make sure that if we get hit by the Russian, for example, not to just start an Armageddon or something like that. I wonder if we have the new generation for mutual assured destruction.
If you want the first one, I'll answer the second.
I'm not sure I could differentiate between the two, but I think that certainly with the big players, and I kind of tried to touch on this earlier. Yes, ma'am? Are you okay? So between the Russians and the U.S., if we were to laze one of their reconnaissance satellites, we could expect that they would do the same, right? And generally, we're not willing to pay the price. So I think we already have in space between the two superpowers a form of mutually assured destruction that's been going on probably for decades. What worries me are the third and fourth and fifth countries that come down the line, a little bit like you're seeing the transnational actors in the global terrorism thing. Some of them could even be non-state folks. So I would worry less about the Chinese now than in 2007 for sure, but the Chinese, the Indians, the North Koreans, maybe even somebody. The really scary thing is it's one of these third world actors gets a hold of a nuke and lofts it into orbit, and that would be a really bad day. But I think in order to keep that from happening, we need to have international cooperation on a scale that we're not really getting today to make sure that those kind of capabilities don't fall into the wrong hands. That's the one that keeps me up at night more than worrying about the Russians and the U.S. going at it. So
I'd like to add to that a little bit and also build on what Dr. Grego said earlier. You know, the principle behind mutually assured destruction was, regardless of what one of those nations did first, it was always assured that there was going to be a response. You cannot take an act that would put you in an advantageous position because your adversary had the ability to respond and inflict a commensurate level of destruction and damage on you as well. And that's what made that stable, was there was not an incentive to act first. Unfortunately, today I would argue in space we're a bit of in a posture that's a little bit unstable. We have large systems. They're very vulnerable. They're very capable, and they're vital to a whole lot of things from a military standpoint, from a commercial standpoint, from a civil standpoint. So there's a lot of incentive to act first and remove that capability, whichever side you look at. Because if you look at the Russians and the Chinese, they're building those capabilities as well. So I think two things have to happen in that regard. The first is, I think, clarity of behavior. I think clarity enhances stability in terms of when certain acts are undertaken, there's some understanding between the parties as to what that may or may not mean, what's appropriate, what's inappropriate. There's been some discussion of that. There's knowledge of that. organizations, countries have the opportunity to describe and say, here's what we believe to be aggressive and hostile and not. So the first thing is that clarity brings stability. The second is a need to be able to build and field systems that are more resilient and more defendable, so that any potential one adversary looking at the other says, if I attempt to act first, I'm not going to achieve the intended effect. That also lends toward what I'll call that the balance that says, I'm not going to act because if I do, I'm not going to achieve the desired effect. So clarity in terms of what we believe are the appropriate sets of behaviors, and systems that are resilient and defendable, I think lend more to stability toward, beyond what we have.
Thank you. So right here, and then there's one at the back to follow.
Excuse me. I don't have a question as much as I have a response to the view of human nature that the general put forward. I would posit that the human nature that is involved in historical warfare is a subset of humanity. And that subset consists of people with access to power, either legitimately or illegitimately, technology, assets, funds, and with all due respect, mostly men. And I do think that saying human nature requires preparing for war creates a self-fulfilling prophecy which sets institutions in motions that have the purpose of war. And I think that view of human nature does invite quite a bit of debate.
Thank you. And I think it highlights the tension. That's why I asked Dr. Grego as well. When we have these manuals, I'm involved in the WMERA project to develop a manual. I believe that the clarity on the law of armed conflict may actually help to reduce the tension, the lack of clarity that can lead to conflict. But there is always that tension. Are we not, therefore, writing out the instruction manual at the same time? There's a question at the back.
Hello, this is a little less of an ethics question, and for any of the panel, if they would like to answer it. You talked about debris in space and how the orbits in space are kind of a finite space. Are there any active efforts to start clearing this space or trying to eliminate this debris from an environmental standpoint and also from a finite space standpoint?
Do you want me to do that one? Oh, okay. That's a great question. So, seems like you should be able to clean it up, right? Well, so there are some projects to do that. There's, I think something was just launched yesterday. Forget what it's called, but it's an active debris removal. It might even be called active debris removal project. And, so you might think you're going to take the big pieces, which should be the biggest problem, because if something hits one of those, it creates a lot more, and take them back down. So there are some technologies to help mitigate the problem. Who's going to pay for it? Who wants to do that? Who's invested enough to do that? Is an open question. But also, the general made a really good point that a lot of the objects, and there are many, many of them, are small. Even something a marble-sized could be catastrophic in a collision. So clearing, and we don't track those. We can't. They're too small. So, like, what's a big marshmallow to catch them? Space is actually really big. So there are lots of it's not easy, and space is big. So I know we just told you it's a problem because it's filled with debris, but it's also, the reason is that they go around and around, so your risks go up because you're constantly going around. It isn't that they're just, everywhere. So collecting a lot of tiny, fast-moving pieces out of a big space is a big technical challenge that somebody has to decide is worth it to pay for.
So,
it's not like there really needs to be a business case. I mean, the only way that I could see that anybody would go get any measurable amount of debris out of orbit would be if governments decided they wanted to go do it, because you just haven't figured out how do you make money doing that? But there is one bit of good news, and it happened decades ago, and I forget the name of the instrument, but a lot of the debris that's on orbit today was created 15 and 20 years ago when they used to launch liquid-fueled rockets, and there was no requirement to vent the tank once it got onto orbit. And what happened with solar cycles, 250 on one side, 200 degrees below zero on the other side, the pressure builds up inside the tank, and sooner or later, every one of those stages went off on orbit. So there was an international agreement. So I don't have the facts on this, but I would bet that the amount of debris generated in any given year relative to what it was before we started doing that is at least heading kind of back in the right direction. Problem is, there's a lot more launches today than there was, 20, 25 years ago.
So the space debris mitigation guidelines is what it's a non-binding instrument, but at the very least, what that requires is that nations, many nations have used those guidelines and implemented that into national laws and said, if you want a license to build and launch a satellite, you have to prove to us that you've built into that design how you're going to deal with its end of life. Are you going to use the last bit of reserve fuel to deorbit it? Are you going to make sure that we don't have these kind of risks? So there are steps in place, but cleaning it up is not that easy. So why don't we take two last questions both at the same time, and then we'll have to finish. So one just here, and there's one over on that side there.
Hi, how are you? My question is about I was hoping you could share your opinion on the privatization and the commercialization of the space industry, specifically with SpaceX, Jeff Bezos, Elon Musk, Richard Branson, and what the implication of the privatization and the commercialization of the space industry is on the legal industry.
Great, and this question here as well, and then I'll ask you to respond to both the questions.
Hello, ladies. Hello, gentlemen. So I know that as space military theory increases, there's also a chance of a detonation in space influencing large swaths of land underneath, like an electromagnetic pulse. And I was wondering, with that theory that now national defense is expanding from just above the United States to almost near hemispheric proportions, how that influences necessary military strategy moving forward.
So, Oz, do you want to comment on the commercialization of space, privatization of space?
Yeah, sure. NASA's an interesting organization. It's the only one that I know of where its budget never moves. It's almost constant with just a little bit of money on the upside for inflation. So when you shut down a program, a major transportation program like Space Shuttle, and you're continuing to run International Space Station plus the other 3 or 4 missionaries that NASA's got, getting another government-owned, human-rated launch system online by the time you were going to shut down Shuttle was just not doable. So NASA was kind of forced to go look at the commercial side. And they're looking at traditional guys, the Lockheeds, the Boeings, the Northrops, and then you got these new guys like Blue Origin, which is a Bezos thing, and SpaceX, which is an Elon Musk thing. And they're making progress, as is Orbital ATK. Both Orbital and SpaceX are delivering cargo to space station today, both under contract to do that. And Boeing and SpaceX are competing for, and possibly Sierra Nevada, are competing for the human launch capability that should come online here in the next 1.5 to 2 years. So far, so good. Elon's company, and you can love him or hate him, but his ability to bring those boosters back down and land them and create the possibility at least that they could reuse them could really significantly bring down the cost of launch, which has been one of the barriers to an awful lot of things that we would like to do in orbit. So I guess I'm optimistic. I think, though, that the reliability of some of those vehicles compared to the more tried and true vehicles like Atlas and Delta, they still have a ways to go. And they certainly have a ways to go before you start putting people on at least one of them.
General Thompson, if you can comment on the, on either
Let me
question.
say, well,
on
the
either question.
first one, let me just say this, you look at your cell phone, your smartphone that you have today, most of the technology, if not all the technology in there was developed by various arms of governments, mostly the United States government. But it was really the entrepreneurial spirit and the commercial market that unleashed what you have today in that smartphone. I think and I hope we're on the verge of that with commercial space, and I'm excited and looking forward to that.
Thank you. So we have run out of time. I think the thing that the Center for Ethics and Rule of Law really aspires to do is to bring debate to the forefront around issues. And I was given very clear instructions by my director, Clive Finkelstein. Make sure you pose questions that's going to bring out their opposing views. Unfortunately or fortunately, the thing that continues to hearten me, the more I work together with folks in the military who work in space, with people from the peace community, with people from civil space operations, there's actually very much a shared view, a shared normative standpoint that there's a concern about weaponization, there's a concern about tensions that could lead to a conflict in space. But in fact, we would all lose if there were an armed conflict in space. And so I'm thankful for all of your comments and your insights. I hope that you've all learned a lot from this very enlightening panel. I'd like you to join me in welcoming our speakers for sharing their insights with us tonight.
It was fun.
And I'd like to thank, of course, all of our panelists and Dr. Cassandra Steer. And just before we break, I would also like to recognize Dr. Harold Berger. So I mentioned our organizational partners, but our individual partner is Harold Berger. And Harold is a member of the CERL board. And most importantly, he created, through a gift, the Berger Air and Space Law Collection, which is the premier collection of primary documents and commentary relating to space. So at our reception now upstairs in the GOAT area, I'm going to have a chance to thank Harold further for his contributions, but we also have some of the items from that collection on display, and we'll tell you a little bit more about that collection and talk about how Penn Law is positioned here, thanks to Harold Berger. So please join us for a reception and join me again in thanking all of our sponsors and